There you go.
There we go. Hold on a second. Everything we're recording. Things
Can
are
you see
good.
me okay?
I can see you fine. I see a
Okay.
TR7 in the background there. It's just
Okay.
awesome.
Hold on. Oh, I know what's happening. The little preview of you was covering over me, and it did look like I was there.
Oh, there you are. You are definitely here.
Yeah, yeah.
All right. How are your levels? Your levels good?
I think they're good.
All right, good. Pete Giuliano. It is Tuesday, the 7th of March, 2023. Pete, what number are we? It's been about I've been out of sync.
I first want to say local time is 5 a.m.
It's 5
a.m. local time. This
it's
is 2:44. SolderSmoke
Thundersmoke
244.
245.
Crank it in, Robert. Crank it in, Ralph.
Crank it in, fellas. There it is. He's back. All right, man. I am so happy to see you back here, Pete. You know,
It is. It was the strangest thing, Bill. You get a blank screen for Skype, and evidently we're not all connected to the same server. Evidently, on the West Coast, the servers for Skype was having a problem that morning. You didn't have a problem, but you get a blank screen and you check on the internet. Said, "Yeah, we're having a
well,
problem."
Pete, this is what happens when you start messing with software. I'm telling you,
Yeah, yeah,
this
yeah,
didn't
yeah,
happen in the analog days.
yeah,
This is
yeah, yeah.
that explains a lot. But Pete, I just noticed something that the entire solder smoke community went into what I would call a collective funk with your absence. I got so many messages they were all saying, yeah, the podcast is okay, but it's not the same without Pete. Where's Pete?
Yeah.
So we're really, really glad you're back. The funk, the cloud has lifted from the podcast. We're back. We're back in the old days. All right. So let's get right to it, Pete. You got the TR7 there in the background. People have been reading about this on your webpage. Tell us what's going on with the TR7.
Well, first of, I want to share a couple of things. Initially, I have a new blog. Okay, it's hamradiogenius.blogspot.com.
That's you,
Ham,
man. That's you.
that's
You're the
me.
ham radio genius.
Hamradiogenius.blogspot. And that's documented there. So on December 25th, my son and his lovely wife Amy show up here with a big box, and they said Merry Christmas, and they hand me this box, and I open it up, and it's a TR7, and he said, first of you should know it's a parts only tech special. And we figured you'd need something to keep you out of trouble. So, Merry Christmas. And so it did not work on receive or work on transmit. And the strangest thing is you'd whistle through the bands. On the lower bands, the display would read 95 megahertz. That's on 20 meters and below, and 20 meters above 20 meters, it would read 10 megahertz. And there's actually two VCOs in the TR7. One that covers the lower range from 1 to 15 megahertz, and then the upper range 15 to 30. So I did a little sleuthing there, process elimination, and I said, I'm not getting a VCO signal into here. So I pulled the VCO card and I substituted an RF signal generator in there, and it worked. So I said, aha, that's the problem. And then as it turned out, it was not the VCO itself, but there's one op amp in there that's a summer that sums these various frequencies, and there was no voltage. There was no voltage on the op amp. And they have an internal power supply that is a DC to DC inverter. So it takes 10 volts and makes it 24, because one place in the whole transceiver uses 24 volts DC, and it's on that op amp. So I said, okay, let's try another test. I put the VCO back in, connected 24 volts to that pin. Boom, it worked. It was a 38-cent 78L24 three-terminal voltage regulator.
But
It was out.
this is a beautiful troubleshoot. You know, we often talk about this. What makes a good troubleshoot? What makes a bad troubleshoot? A bad, kind of a less than satisfying troubleshoot is when you discover, oh, it needs a squirt of deoxit or something like that. But this is a really beautiful one because you found a bad component. in that whole mass of circuitry that we see
Yeah.
around behind you, there's one little component, one thing that has gone bad. And I really like the deductive logic that you use in figuring out what was wrong. You know, Dean was commenting to me the other day because I was telling him a similar troubleshooting story, not quite as exciting as yours, but similar. And he said, "Well, this just goes to prove what Pete always says: if you know stuff, you can do stuff."
Yeah, right.
So that when you're sitting in front of that thing, you haven't even opened it up, you haven't even really looked at it yet, but you're kind of getting an idea where the problem lies. So what
Yes.
happened once so you replaced the part, right?
Yeah, replace the part, and then I was seeing some issues with power output on the higher bands. It was less than what you would expect, and receiver sensitivity seemed to be down. There are three pin diodes off of one of the filters. One of the pin diodes is in the transmit leg, and two of the other pin diodes are in the receive leg. And actually, I should back up and say that the TR7 is quite a sophisticated design. You know, we always talk about bandpass filters. What they do in the TR7 is have a front end low pass filter and a back end high pass filter, so that essentially it forms a bandpass filter.
At audio?
They have no RF.
Wow.
RF. They have a low pass filter. The reason low pass filter when you TR, the RF brick is introduced in between the high pass filter and low pass filter, so that the RF brick has the low pass filter following it. But it's a slick way to get a bandpass filter. So there's some pin diodes, and these are 100-watt pin diodes, not little teensy ones, and they cost $9 a piece. So I did find them, and I replaced them. But replacing them, Drake built some really nice gear, but that TR7 was not designed for manufacturing and assembly, because to do servicing, you need a special set of extender boards. And if you don't have those extender boards, you got one arm tied behind you, and they're just not available. And so I'm almost considering making some, and I can do it because I'll just take a chunk of PC board and I have the pins and I can do all that.
Pete,
But I
you
mean,
could market this. You could market this on the internet.
Yeah.
And I was telling Dean, it'll be amazing. You'll make like dozens of dollars.
Yeah. Well, it's interesting. If you can find a set of boards, guys are selling them for about $150, $200, and they're nothing more than a PC board with some pins on the end and a socket in the other end, so that you can plug things in. So, yeah, it's kind of cool. But anyway, there's quite an on the Drake reflector. There's two kinds of people on the Drake reflector on the TR7: those who know and those who don't know. And the most vociferous are the ones who don't know.
But they're going to tell you what to do, right?
Yeah. They tell you what to do. So anyway, I've got it working. I've had it on the air, and as a matter of fact, I replaced the pin diodes, and you had to do it in situ. You could not pull the board out. And one thing they suggest is you pull the shaft out of the band switch. It's a 10-inch long shaft, and try to unscrew the things. And it's just a mess. So I found a way, and I invested $6 in a wonderful tool. I never had one of these tools before. A dental mirror.
Oh, yes.
Dental mirror.
Oh,
yes. I
yes.
got to tell you, they put the dental mirror in a flashlight.
And this could lead to an entirely new career, Pete.
Yeah,
dentistry.
A dental mirror. So,
amateur dentistry.
Yeah, so you're able to, with tools like that. So I replaced the pin diodes, and there was a marked improvement in receiver sensitivity on the higher bands. Matter of fact, on this contest weekend, I got on 10 meters.
You were on 10 meters. So was Dean.
10 meters, and I worked Japan and the Caribbean. Just guy called CQ, call him back, they come back to you. So 10 meters is kind of a hot band, which I'm going to steer away from the TR7 and get back to my new blog and to Todd, K7TFC. He has a whole bunch of new modules out, and he just listed some new ones on his website yesterday, mostly DIY RF. I am dedicating myself to building a new 10-meter single sideband transceiver on the blog using Todd's modules.
You know, Pete, great minds think alike. Because just yesterday, I was talking to Dean, and I said, you know, I'm thinking about ordering the 10-meter element for my hex beam antenna, because I have it up there without the 10-meter element. Then I said, wait a second, I'm going to get the 10-meter element. I might as well get the 15-meter element at the same time. And then I said, wait a second, I can build a transceiver that'll cover 10 and 15, and it makes it all worthwhile. And I was also thinking about using Todd's modules, especially the TIA modules.
Yeah, actually, what's of interest, he has a dual gate MOSFET module, the BF998, and there's a wonderful design by Wes Hayward, a 50 megahertz wideband amplifier using the BF988. So it's a dual gate MOSFET, it's a little board, and he also has the BFR 106 board with the part soldered to the board.
Oh my gosh, you know, this is something we've been talking about. I'm glad you mentioned the Todd's board, because I saw that you and Duane were talking about the BFR 106. The BFR 106 also came up when I was talking about how to kind of boost the output of my microBitX transceiver.
Yeah.
Allison, KB1GMX, had recommended that one of the mods to do this was to replace the BFR 106. But I kind of chickened out because the thing is so tiny. It's a tiny little surface mount part. I got them. I have them here from Mauser, but I haven't done it yet. But Todd's board, if he has the BFR 106 on a board,
yes,
that might save me from the dreaded fat finger syndrome.
And it's got 3 pins, and you just solder a wire, so then it becomes like a plug-in.
Oh man, okay, I'm gonna get in touch. This is a good opportunity to plug Todd's excellent service, mostly DIYRF.com. We got a link up on the right-hand side of the blog page. Click on it. You'll be taken to the world of modules and great products that Todd is making available out there in Portland.
My new blog has about 4 or 5 simulations with a BFR 106. One of them can go all the way up to 2 meters flat.
Wow.
Flat. Another one, I diddled with Allison's design because she kind of had a hump in it, and I found a way to flatten the thing out. So the data is on the blog about the circuit. It's basically her circuit, but I changed some of the components, some of the values. And I actually ran one of those out all the way out to 200 megahertz flat.
Wow.
And it's
so, you know, I might have to order the 6-meter element for the hex beam too.
Yeah. Flat.
You're taking us into VHF, UHF territory.
Flat. And I even have a circuit board design where you can take the device and put it on the circuit board. You can cut it on the CNC, or you could probably put together Rex's pads. But I'm going to test this circuit board out. And the other thing is, I can see that as an IF amplifier in addition to a steerable amp driver like Allison used, but also an IF amp either side of a crystal filter, and he of course has the crystal filters. So on my blog, I have a block diagram of all the blocks, and then I put an asterisk, what you can buy from Todd. And that pretty soon is getting all filled in with what you can buy from Todd. So there's no ADE1. You know what to use the ADE1? He's got a board for the ADE1.
Man, this is going to be like, you know, it's like the old saying, we got a board for that, you know?
Yeah.
So go to Todd's site. That's excellent. That's really great.
Yeah.
So that Pete, the TR7 is looking good. It sounds like your son and his wife gave you an excellent Christmas present.
Oh yeah. Well, the year before they gave me a TR3.
But the thing is, they have ingeniously selected devices that have a good fault in them.
Yes.
Reminds me of my old buddy from Vienna Wireless Society. Who when he would go to the podcast would ask the guy, "Does it work?" You know, when he was going to buy a rig, and if the guy honestly said, "Well, no, it doesn't work," and the guy but the Handfest guy would look at him and say, "I pay extra for that."
Yeah. Well, you know, the thing that's interesting is I was forced to really look in the inside of the TR7, and firstly, I should tell you, if you bought that radio today, it's $10,000.
Wow.
Yeah.
TR7.
Yeah. I took what it marketed for in 1970, and the value of $1, 1975 versus today, 10 grand.
I know,
And
it's
there were
amazing.
such
It's amazing.
such advanced. First of all, they had no microprocessor in there, as many of the radios following that did. But everything was done with discrete logic,
Yep.
gates and NAND gates and NOR gates and what have you. And the other thing that's interesting is there's a switch on the back. You hit the switch and you plug in there. It's a 150 megahertz general purpose counter. I mean, they just threw that in,
Oh yeah.
just threw that. But I mean,
Oh
there are
man.
just so many ingenious pieces of technology in there, and it really it's a PLL, so they lock it. Now this particular one, I've had a couple TR7s before that drifted. This one does not drift like the other ones, and it's an early model. It's serial number 1394, and they built about 12,000 of them.
Pete, what year was it? Were they building the TR7?
Starting about 73 up to about 80.
Well, I don't want to stop. We're going to go back and talk back and forth, but this is a good way to kind of segue into. I'm going to skip ahead to one of the things on my bench, which is my old HP 8640B signal generator. And everything you've said about the TR7 kind of reminds me of stuff that was going on with the HP 8640B signal generator. I checked the serial number and decoded it on the model that I have. I have one that was given to me by Steve Silverman, KB3SII, just before he moved out of New York City. And Dave, W2DAB, traveled down and picked it up. The thing weighs more than 50 pounds, carried it up in an Uber to hit from down on lower Manhattan all the way up to the Upper East Side. And I picked it up a few weeks later. But, it too has a lot of the features that you just described in the TR7. It too has these same kind of simple logic gates, NAND gates, OR gates, NAND gates. But also what you said about the extension boards. One thing about the HP 8640, I thought about you a lot when I was working through it. I said to myself, Pete would love this thing because it's a design with the repairman in mind.
There you go.
When you open this box up, the first thing you see is a whole bunch of kind of sub-assemblies, but each sub-assembly has clearly written on the top how to access it, which screws to remove, and a block diagram of what's going on in that sub-assembly. So you could just go into it and you start moving through it and you see where everything is. Now you could use extension boards, and there were extension boards available for the HP 8640. I don't have any, but I was still able to troubleshoot this thing a couple times. I had an earlier problem with the HP 8640 that was caused by one of the tines, one of the little tiny tines falling off. A guy up in Canada, VE3EAC, really helped me with this. Dave, VE3EAC, he said to me, watch out, you probably lost a tine. And I said, well, can't a tiny little thing like that can't take down this big, humongous, kind of Apollo-looking HP 8640. But he was right, it did. I flipped it over and I found it. But fast forward to the more recent problem. I had problems somewhat similar to yours, not quite as kind of satisfying in terms of repair and troubleshooting as yours, but kind of good. I was looking at it, and my HP 8640 all of a sudden started to go intermittent. It would work, and then it would not work. I'd be working on one of the direct conversion receivers, and I'd turn it on, and instead of the glowing numerals that we see in the display behind you on the TR7, I would have like a blank screen. The thing was completely out. So I started thinking, man, this might be the end of the road for the HP 8640 because it's an older piece of test gear. I could think I said I decoded the number or the serial number, and the one I have was manufactured in 1982. 1982. There were many different versions of the HP 8640 built for many different uses. Some of them were built for the Patriot missile system. So mine was built in 1982. But it kind of annoyed me. And then I started looking at sort of replacement signal generators, and I talked to Dean about what kind of replacement. And almost all the replacements were either way too expensive or way too cheapo. I mean, you quickly, as soon as you got down in like the sub $200 range, you started finding products with terrible names. Like Dean told me, he said he's been using what's known as a Coolertron. Coolertron with a K. And then I have been using a product that I think the name, it's almost pornographic. It's the FieldTech.
Yes.
FieldTech signal generator. I mean, come on, guys. You could come up with a better name than that. And you open the boxes up on these things. They're all using the same kind of plastic box. You open it up, there's all kind of wires floating around in there. There's a couple little boards hot glued to the plastic. Yuck. The contrast with the HP 8640 couldn't be stronger. So then I was thinking about something that you said, Pete, when I started looking at this thing. First of all, I thought about when you know stuff, you can do stuff. But without even opening up the box, I started saying to myself, what could be causing this fault? Without even going in there. And I said, wait a second, there are a couple of different systems on this, several different systems on this device that are not working at the same time. There's no RF output. I looked at the scope, no RF output at all. No, the counter is obviously not working. And
Power supplies.
There you go. Boom. That's it. Once you see several different subsystems not working at the same time, you say to yourself, what's the common circuit? The common sub-element there is the power supply. And also, as we know, in a lot of these devices, especially the older devices, the thing that goes out first is the power supply, because it's sitting there, it's all the time, it's handling a lot of current, it's generating heat. There are components in there that go bad. So I started looking at the manuals for the HP 8640, and I was thinking, oh God, this is going to be a really complicated, difficult repair. And something caught my eye. In one of the lines of the manual, and the manuals are like mind-bogglingly long. They could be like 200-300 pages long. And there are different manuals for different versions of the HP 8640. But I was looking at one, and I got down to the section where we're talking about the power supply. And it said there are there are 2 boards that handle the voltage regulator and the power output from the power supply. And here's where HP's genius came in. The line also said there are LED lights at the top of the board as you look at it from the top. And the lights will be on if the circuit is working properly.
No lights, no circuit.
Man, so I said to myself, God, it can't be this easy. So I put the board on the workbench, which was a chore because it's 56 pounds. You could hurt yourself with this thing. So I put it there. I pulled off the top. The top comes off very easily. It looks like the way the top comes off on the TR7. Those 4 little screws, I popped it open. And I looked at the diagram in the manual, and I looked, and sure enough, there are the 4 LEDs. 3 of them are lit up. 1 of them's out. Okay, so that's like the first part. So, okay, look, I've identified it. But here's the other clue. It's intermittent, all right? It's intermittent. And I said to myself, wait a second. Those components were soldered onto that board in 1982.
Cold solder joint.
HP. Well, it might be, but I was thinking, no, it's probably not the solder joints, because the people who put those boards on together obviously knew which end of the soldering.
Was it plug in a socket or something?
Plug-in socket. That's it. So I just took it and I wrapped it a few times, and I could see the light going on and off. Right. So I said, I bet you if I take that card out and reseat it, the board will come back on. So I pull the card out. I look at it. Now it's got gold contacts on the bottom. And one thing about the HP 8640, it's full of gold, which I think is leading to the demise of many of these devices. Guys are buying them up. We know that at the local Hamfest, people are buying them because they just want to get the gold out of them, which is terrible. But I take it and I wipe off the gold contacts. I give it a spray of deoxit. Wipe it off again. I don't think the problem is the gold contacts. I think the problem is the socket. Seating of it. I just reseat it, put it back in there, fire it up again. The light comes right back on.
There you go.
I put the case back on it. I turned it on, and the HP8640B lives again. Man, that is an amazing signal generator. So I'm going to keep it going. One of the things is the plastic gears. There's some plastic gears in there that go bad over time.
Oh, you found the guy with the metal gears.
I got them. They're sitting there. One of these, when they really go bad, I have the brass gears produced in India.
Yeah.
And I'm ready to install them. So the HP8640, I think, will go on for another 50 years. Here we'll be good with the HP8640. But it was a satisfying repair, Pete. It reminded me of what you were saying about the TR7.
Yeah. Well, look, just think of the thought. Pop the lid. All lights lit. Yeah, good. Power supply's okay. All lights not lit. Power supply's a problem. It's just the way they approached it.
It's what you said. It's designed by thinking ahead to how somebody's going to troubleshoot this thing. And that's something that we don't see in a lot of the more modern equipment. The assumption with the more modern equipment seems to be they'll just get a new one and throw this thing out.
Yeah, throw it out. Throw away.
The HP8640 lives again. And it actually has caused me to think about some of the other vintage test gear that I have here. I mean, I have a Tektronix 465, a Tech 465 scope. Almost all of us had Tech 465s. Farhan had one. Wes Hayward had one. You probably had several of them. And I chickened out on fixing this thing because of the plug-in transistors. I'd bump it with my elbow, 3 transistors would fall out. I think, oh God. But I still have it sitting out there in the garage, and I don't know. The HP8640 thing might get me back on that trail. Pete, talking about going back on the trail, the CK722 has come up again.
Jeez.
Man. And they're talk about a cult following. This thing has a cult following, and I think without realizing it, you might be one of the leaders of the cult.
Yeah. You know what I didn't realize? They were devices that didn't pass the test for higher specifications. I think it was a CK761. So if it didn't pass, they just put a new number on it and says, "Oh yeah, it's good enough."
Well, this is an old story. This also explains why we're seeing all these kind of what people think they're counterfeit, like counterfeit IRF 510s or counterfeit, P and the 2N2222s. And you and I were talking. Who's going to think, hey, I know what we'll do. Let's counterfeit the 2N2222. It's crazy. Why go through all that trouble? But I think what we're really seeing is devices that were manufactured that for one reason or another didn't make one of the specs. So instead of throwing them all away, they just put them in a bag and they say, oh, let's try to sell it. And so people do buy them and they're unsuspecting and they think they're getting a good product and they're really not. So but that explains it.
That's kind of interesting. It harkens back to the days when I lived in Mesa, Arizona. And believe it or not, around Mesa, Chandler, and Phoenix, there's a lot of electronics manufacturing. Motorola, Honeywell, Intel. I mean, all these guys there. So there's this place called Apache Reclamation Electronics. And they had, I'm not kidding you, a barrel of transistors, unmarked transistors. And the deal was you put your hand in there, and whatever you come out with, you put it in a paper bag, and they charge you $1. So if you got big hands, you get a lot. But you take those home in a tester, and for the most part, they're just okay for general purpose, like audio. But I mean, they may have been RF transistors, and they didn't meet the RF spec. But I mean, I was in transistor heaven, for $1, whole handful. But I mean, they just got rid of them, and maybe they just said take them away, and this guy says, we'll make a deal, charge $1 for a handful of them. So yeah, a lot of that stuff surplus is stuff that didn't match the specifications of the test. Man,
so I wish we had those kind of places now. Now we all have Mauser and DigiKey and everything else, and it's a lot less there's a little bit less adventure there.
There's kind of a postscript to my 78 L24. See, I knew it was bad. I knew it was bad because there's no voltage coming off the pin. So there was voltage going in, coming off the DC to DC, but nothing coming out of the regulator. So
you need a 24-volt voltage regulator. Right?
Yeah. So I ordered them from DigiKey. So It got stuck in a snowstorm in Grand Forks, North Dakota. All this weather, somehow you don't think about how things can be impacted. But believe it or not, my 78 L24 took 10 days for me to get because it was stuck on a truck in Grand Forks, North Dakota, which also has a parallel story to it. We had a podcast on August the 5th, and that was the day after I had my tooth removed. Okay.
Right.
So on the 23rd of February, I was supposed to get my tooth. Guess what? It got stuck in a snowstorm on a truck from Colorado. So next Monday.
Your replacement tooth?
Yeah.
Oh my gosh. Supply chain, Pete. It's everything. Supply chain.
Then Psalms calls says, we got some bad news. Your tooth is missing on a truck somewhere.
It's probably floating around now somewhere out there with the 24-volt regulator.
Yeah, they finally got it. They finally got it Monday. I get it next Monday. Yeah.
All right. Well, good. I mean, that's excellent.
I mean, we never think about weather and how global warming can affect our hobby, but it does.
There you go. Well, Pete, this is this show is full of interesting segues because you're talking about the voltage regulator. I'm going to use that to jump into a discussion of the high school direct conversion receiver project that we've been involved in. And what it is, Dean and I, really inspired by Farhan over there in Hyderabad, have gotten involved in helping a group of high school students build a direct conversion receiver. And one of the things that Dean and I were thinking about when we started trying to decide what kind of circuit they should build, one of the things we decided to do was use all discrete and analog components. The objective being that the students would, to the maximum extent possible, understand how each and every component worked. While we were doing the very first board we did was a kind of a variable inductor or permeability tuned oscillator, the VFO, because we wanted the students to experience early on a sense of satisfaction that they had built something that actually does something. So on the very first day, they were putting together the oscillator, the variable frequency oscillator, which is really a PTO. And we're working there. The students are very sharp. And one of them looks at me and she says, "Why are you using a varactor diode? Why are you using a Zener diode? Why a Zener?" And I explained to her, I said, well, because we want to try to regulate the voltage going to the oscillator. And she says, why don't you use a voltage regulator? She was obviously talking about a chip, because in other circuits, she had come across people who were just putting a chip in
a 3-terminal regulator.
Right. And I just said, it's an excellent question. But the thing is, you could use a 3-terminal regulator, and it probably would be easier, and it probably would be better, because you wouldn't have to worry about the resistor going in and everything else. But in our design process, we wanted to use components that you could see. So instead of that, we're using the Zener at 8 volts with a resistor to keep the current from burning the thing up. And that's why we're doing it. So she was like, oh, okay. So it was one of these kind of wake up moments. Now, a few minutes later, on one of the other boards, the students wired in the Zener backwards, right?
Oh, okay.
And I was looking at it, and I was trying to figure out what was going wrong, and I kind of just touched the Zener, and I could smell the smoke coming out of my thumb.
Yeah.
So it's like a Zener tattoo on my thumb.
Yeah.
Students were shocked, but I said, no, this is okay. This kind of thing happens. You got to be ready to roll with the punches here. Hey, but we've been having a lot of good luck with this direct conversion receiver project. We have kind of followed Farhan's guidance, and Farhan always points out that almost all radio circuits can be divided into 4 different categories. You've got your amplifiers, you've got your filters, you got your oscillators, and you got your mixers. And almost everything we do with radio, the circuitry can be broken down into one of those 4 categories. So we have 4 boards on our receiver. There's a bandpass filter. There is a permeability or variable inductor tuned oscillator. There's a diode ring mixer, and there's a discrete component audio frequency amplifier. So, and we're building them in stages. We're insisting with the students that they build a stage and then they test it, and only when it's tested can they move on to the next one. So we've already done the permeability tuned oscillator. We've done the mixer, which was harder than we thought. And today we're going to go with the students this afternoon. We're going to start building the bandpass filter, and so it's really going very well. The oscillator, it worked just the way we wanted it to work, and it gave them the sense of, holy cow, I can build something that produces RF. It almost is like the experience that many people had with the Michigan Mighty Mite, where they just fired it up and they could see and hear that they were producing RF. I brought to the school a little DX390 receiver, and that was really a lot of fun for the students, because once we saw that they had got the oscillator to the point where it was actually oscillating, I would turn on the DX390 and you'd hear the thing, you'd hear them as they powered it up going whoop whoop whoop, and they were producing RF. And when we first did it, I could tell that the students were kind of incredulous. They thought that this was somehow a gimmick, that I had somehow connected the receiver to the oscillator and we were just listening to tones. But I handed one of the students the DX390 and I told him, walk around the room with this thing as we turn the oscillator on and off. And he did. And as he had the receiver in his hand, he's walking around the room. And, of course, they're continuing to hear the tone from the oscillator. I got a kick out of this, Pete, because I'm rereading a book about Marconi called Thunderstruck by Eric Larson. And they talk about how in one of the early demonstrations of radio, they actually did the same thing. The people in the crowd figured that it was some sort of wired trick. And to prove to them that it was wireless, they took the receiver and had the guy hold the receiver and walk around the room so the crowd could see that no wires were involved. So it's been really great. Now, one thing I want to not brag a little bit, but this is something we'll talk to the students about. I actually have made a contact, a QSO, with the receiver that they are building. So Dean and I have been joking that in the course of doing this, both of us have been building multiple examples of the receiver, because every time we want them to build a board, we kind of prep by building the board ourselves before we go into the classroom. So we've got kind of a fresh understanding of the problems that they'll face.
Yeah.
The result is that the boards are building up, and I am now on receiver number 4. I built
wow.
4 of these things, 4 40-meter direct conversion receivers. And so I was sitting here and I was thinking it would be good to have a little transmitter that they could, a little single stage transmitter that they could turn on in the lab and hear, either in the DX390 or in the receiver that they built, the signal. So I started looking around. I was going to build a Michigan Mighty Mite, but I remembered there was another circuit called the 10-minute transmitter, the 10-minute transmitter. It's even simpler than the Michigan Mighty Mite, which we of course love dearly, but this is simpler. So I threw it together, and it's only got 8 components, including the key. 8 components, including the key. It's powered by a 9-volt battery, and I built it on a little kind of maybe a 1x1 piece of PC board. And I was thinking, okay, this is great. And I can now. I said, I was sitting there in the bench one morning, and I said, let me key the thing and see if I can hear it on the receiver that they built. One of the examples I have here. And then I suddenly said, wait a second. Why don't I try to make a QSO with this thing, with their receiver? So I take the receiver and I hook it up to the antenna. I take the transmitter and I hook it up to the antenna. The antenna had a low pass filter in it because of the antenna tuner that I had there. And I'm starting to tune around, and I start sending CQ. And I can see on the reverse beacon network that this thing is getting out. It's on 40 meters. It's on 7040. It's putting out about 100 milliwatts, and it's being received by RBN stations as far north as Boston and as far south as Roanoke, Virginia.
There you go.
It's getting out pretty well. So I'm sitting here and I figured let me just call CQ again. I called CQ one more time, and all of a sudden somebody comes back to me with this little tiny QRP transmitter. I mean, I'll put a picture up on the blog. I have it up there now, but the key is just a little micro switch that I'm keying. And the guy who came back was Allan, W4AMV, in Raleigh, North Carolina. And I was so excited. I managed to get some video of the contact of me transmitting and receiving Allan's signal. But then I realized I know Allan. I know him because Chris, KB4PBJ.
Oh, peanut butter and jelly. Yeah.
Peanut butter and jelly had alerted us to Allan's amazing homebrew creations. And I had carried a report on this on the blog. So I said, wow. And I sent him emails, and I said, this is just fantastic. And I had to ask him, I said, Allan, were you on a homebrew rig when you called me? And he said, yeah, he was.
Homebrew to homebrew. There you go.
Homebrew to homebrew and everything else. So I will tell the students about this today, and I think they will be really impressed. You know, one thing I want to point out, we got the crystal, the 7040 crystal from Bry's AF4K's company. Bry passed away a year or two ago, but the company continues. So his crystal company is there, and they were able to send me a crystal for 7040, and that's what I used for this QSO. So thanks for that. But the 10-minute transmitter, Allan at W4AMV, really fantastic stuff. And, you know, one thing I want to point out also, Pete, is that, you know, Farhan's idea has really taken off around the world. And we've got people all over the world involved in either building the receiver and helping us test it, or going a step further and using the project to do something similar with their own students at their own schools. So we have Farhan in Hyderabad. Farhan has had amazing success with this, and he sent us pictures showing his classes. The thing that's amazing is the pictures look very, very similar to what we see in the lab here in Northern Virginia. So I'm going to tell the students today, you are not alone. There is another group of high school students who are engaged in
across the globe,
using the same coil form for the PTO, also building 40-meter direct conversion receivers. So I think they'll get a real kick out of that. I put these pictures up on the blog. People who are interested should really take a look. It's very encouraging. We also had Rick, N3FJZ, who built the exact copy of the receiver, tested it. That was really helpful. Walter, KA4KXX down in Orlando, did something very similar. Andreas in Germany, DL1AJG, is running a course for his students. I think he's got students at university or grad school level, and the course he's running is called Electronics for Biologists.
Oh, yeah.
And so we're good luck with that, Andreas. It's fantastic. Peter Marks, VK3TPM, down there in Australia. Pete, he's been fighting the siren call of the SI5351.
Oh.
He feels the urge, and he's been encouraged. Paul Taylor, VK3HN, has been encouraging him. I said, no, fight the feeling. Stick with the analog. So Peter is really close. He's got it running. But, you know, I could hear you. I could hear your voice in there, Pete, and he was complaining about instability of the oscillator.
Yeah.
And I said, well, just nail it down. Get yourself a board and screw those things down on there. Increase the mechanical stability, and it'll be more than acceptable. Another Australian, VK2BLQ, Stephen, built a really beautiful one, and I put a picture of that up on the blog. I also put both Peter and Stephen's rigs have been featured on the blog. There's another fella up in Western Canada, Daniel, VE5DLD. He's built one, and he plans on doing one with at least 3 of his students. There's a guy down in Brazil, Orlando, Papa Yankee 2 Alpha Nancy Echo, is building one too. So we really think this is a good project for students because it combines kind of the joy of oscillation bit that we got from Michigan Mighty Might with building a device like a receiver that is really kind of useful and appealing to the students. So we hope that other people will take this up. This week we're going to go over to the high school and work on the Bandpass filter. They're going to actually have to wind some toroidal
Ooh,
transformers.
nice.
And I'm going to tell the students that many hams are for some reason afraid of toroidal transformers.
Yes, yes.
How many times have we had guys say, yeah, I'd build that thing that you guys have built, but wow, those toroidal transformers, they seem kind of difficult. So I'm going to go play golf instead.
Yeah,
You
yeah.
know, and we're going to. I think the students like the idea that they're taking on something that is challenging, something that adults that hams have been hams for a long time find difficult. So it's appealing to them, and I think they'll take up the challenge. So we're going to go. That'll be today's project, and then
If
we really just will have one more board. The final board is probably the most difficult, which is good because with each board, their experience in building increases.
skill set improving.
Right, their soldering is improving. Their use of hand tools is improving. It's not as bad as you think. A lot of people have the stereotype that students today can barely change a light bulb. That's not really true. I mean, these students, they're in a robotics club, so they've already acquired a lot of the kind of the manual dexterity skills. And if we just show them how to solder, how to put components on a board, it's okay. But we wanted them to do as much of the build and even some of the design as possible. So today we're going to tell the students, all right, you've got the schematic for the audio frequency amplifier. It's a 3-stage audio frequency amplifier. It's a bit more challenging than any of the boards we built. But your homework assignment over the next couple of weeks is you decide how to lay out the pads on a Manhattan board. And this will give you a little bit of very rudimentary experience in PC board design. You know what the schematic looks like. You got to keep outputs away from inputs. You got to think about where to power it. So you've seen us do this with the other boards. Take the schematic and figure out where you would put the pads. So we'll see when they come in and when it comes time to build the AF amplifier, hopefully we'll be using a kind of a PC board design that's at least partially of their making. I want to say a shout out to Hans Summers because we just stole his designs for the Bandpass.
Yeah,
Bandpass built from the QRP Labs site. But hey, we've been having a lot of fun with this thing, and it's rewarding to kind of take students who are interested in this stuff and just teach them to do something that they didn't know how to do before. And almost all of the students are already licensed amateurs. They've received their technician class license thanks to classes run by Vienna Wireless Society. So when we talk to them, we're talking to them as fellow hams. We're saying, look, you as radio amateurs should be able to do this.
Yeah.
You're doing something. You're starting your ham radio experience with something that most hams will never ever do. They'll never ever build a receiver, and you're going to do it right off the bat. We also had kind of I don't know. There are many kind of poignant moments in this whole thing. When we were doing the mixers, we thought that winding the tri-filler toroids might be a bit much. And also there was a time constraint. We had to try to get the mixer board done in 2 hours or 4 hours. So Farhan had left for me a whole box full of toroidal tri-filler transformers that had been produced by the seamstresses of Hyderabad. And I said to Dean, look, what we should do is just figure out a way to let them use these already produced transformers. I mean, in the bandpass filter, they'll wind their own transformers, but there's no reason for us to make them suffer with building 2 tri-filler, toroidal transformers. But I told them before the class, I said, we have a tradition in ham radio, or a belief, that if you include in your project components or parts that were given to you by a friend, by somebody who's important to you, you're adding soul to the new machine.
Yeah.
I said, so we're going to be using toroidal transformers that were produced for Farhan by the seamstresses of Hyderabad, India. I said, and believe me, we're going to be putting a whole lot of soul in these new machines.
Oh,
when you guys
absolutely.
use them. And I think that idea really appealed to them. I'm going to show them today the pictures out of Hyderabad of Farhan's workshops. And I think this is going to gives them a sense of kind of the worldwide reach of ham radio. But a lot of fun with this, and I really encourage anybody out there who has the opportunity to do something similar, especially with younger people. It's a very rewarding thing. We've told these kids, we said, hey, look, even if you don't continue in ham radio, many of you are going to be electrical engineers or scientists working in this area, and your experience here will put you ahead of your peers and your colleagues because you will have built something with your own hands. You will have melted solder. And a lot of people coming out of these programs today really have very, very limited or none or no experience in actually building something with their hands. So this will put you ahead. And I think that really appeals to them. So good stuff.
Hey, Bill, I wanted to share a couple of things with you on my posting of the 6th of March on the blog hamradiogenius.blogspot. I mentioned in there that Todd sells boards that you can build literally what he's selling now. You can build a direct conversion receiver. And then I mentioned about a series of articles that I had in QRP Quarterly in the 2011. And in there is a direct conversion receiver, but then there also is a matching transmitter. And the schematics are shown there. And there's a couple of things, forget building the transmitter, but there's a couple of things in there may be used if they go to a transceiver. Using an NE555, you're actually keying that, and that's supplying voltages so that you can power on the transmitter just by hitting the key. And the other thing is it's got a mute so that you can mute the direct conversion receiver. It's got a 2N3904. So those couple of pieces, if they go to the transition from a direct conversion receiver to a transceiver with a transmitter and receiver, there's always that problem. How do you shut one off? How you turn the other one on? So
yeah,
take a look in there. It's got the NE555 that when you key the transmitter, you actually key that, and that changes some voltages. There's it uses a VXO, and then there's also a VFO in there for the direct conversion receiver, and you can see there's a shot in there that shows the direct conversion receiver and the separate boards, and it uses a BF998 as a part of the direct conversion receiver. So it's on the 6th of March, has those, and there's some schematic information, but it's mainly the control part that I want to highlight. If you're going to go to how do you handle that part? I mean, that's always been a problem. You got the transmitter, you got the receiver, how you shut one off, how you shut the other off, and how do you go back and forth?
The students were already thinking this way, Pete, because I had one of the students, I was showing them one of the receivers I built, and he was looking, and I could tell he was looking at the oscillator circuit, and he realized that the oscillator is at the operating frequency. So he said to me, well, why couldn't you just make this a transmitter too? And I said, you're almost there.
You're almost there. Don't forget the offset.
Well, yeah, the offset too. But, Dean has been doing something very similar. He's been taking kind of a DC receiver and expanding it to become like a DC receiver and a double sideband transmitter on 10 meters. Pete, he's been suffering. He told me the other day, he said, you and Pete warned me that when you get to the RF amplifier stage, you can run into trouble. You can get into feedback and stuff. And he said to me, that happened in my case. He said, it started happening right around the Chinese Lunar New Year.
Ooh.
And I had a lot of trouble with it. And I went back to him and I said, Dean, you've had so much trouble with this thing. I don't think we could say it was the Chinese Lunar New Year. I think we could go so far as to say it was a Tet offensive.
Yeah, there you go.
So, but he's got it straightened out, and he's been on 10 meters with it. He's been having great fun. And Pete, we're definitely going to look at your circuits. I'm sorry?
I said he worked the contest.
He worked the contest. He worked all kinds of DX with it. It's inspiring stuff. And he's got a really good attitude towards fixing stuff. I mean, he occasionally gets into that point of desperation that you and I and homebrewers all have been to. We told the students about our the nightmare where you start dreaming. In the dream, you start pulling components off the boards, and then at the end, you've got all the components on the board taken off, and it's got a bare board. But Dean has taken the advice, and he occasionally will stop and take a walk and think about things. But he's got it going. And Pete, we're definitely going to look at your circuits there, because one of the things that's really kind of cool about this project is that we have borrowed circuitry and ideas from so many people. I mean, there's a lot of Farhan in there. There's a lot of Wes Hayward. There's some Forrest Mims because of the audio amplifiers. There's diode ring mixers and thinking about diode ring mixers in there. There's a lot of Allan Wolke in there. I mean, so there's a lot of contributions from many different people there. It's been a lot of fun.
And maybe that's a lesson from your students too, is that sometimes you don't have to invent everything by yourself. I mean, it's being able to use the resources you have, and then it's that skill to take that piece and how you put them together. I mean, that's what you need to learn, is how you make that interface.
That's right. And you know, the other thing is really useful in that regard is the Manhattan style of construction. I had students come to me and say, "Oh, I put this pad on the board, I glued it to the board, and now I realize that we don't need it. What do I do?"
Leave it.
Don't use it. Or then I had students also say, "Oh, I should have put a pad there because I need a connection, but what do I do now?" And I look at them and I say, "Glue a pad there." You know, it's the flexibility, the prototyping kind of advantage that comes from using Manhattan style construction. So, I mean, really, really great stuff. Pete, we're at 56 minutes.
Yeah, wow.
We still got to do
shameless commerce, Bill. Shameless
commerce. I forgot about shameless commerce. All right, first, you know, you guys should become a patron of SolderSmoke and through Patreon. That's a really good way of doing it. And I have been posting some fun stuff for the patrons there on the patrons page. So just click up on the upper left-hand corner of the blog page. You'll see how to become a SolderSmoke Patreon person, a patron. The Amazon shopping ads. We had Bezos ads were down for a while, but they're back up. And we've got them on the right-hand side of the page. You'll see some multimeters that I've been looking at. And we also got a couple of Amazon ads on the left-hand side of the page. But if you use either of these to begin your search for any Amazon item, boom, Bezos will send us some money. And also, we mentioned him before, but you should check out Todd's page, and I've got it on the right-hand side of the blog page, mostly DIY RF. If you just click on it, it'll take you right to his page. So thank you for reminding me about the Shameless Commerce Division, Pete. I think we should get right to one other thing. One thing I have up there is multimeters. One thing that this course has taught me is that I kind of need some new multimeters, and I have one. You can see it up there, back up there. It's a multimeter from China. I got it, and it's called like the Astro AI. Pete, it's $34. $34 with same day delivery here. Amazon had it on my front step. You know, so you could argue that it's not perfect. It's not, you know, it's not a fluke, or it's not a $400 fluke meter. It's $34. Tony Fishpool, G4WIF, he said he can remember when we'd pay a lot more than that just for the frequency. This thing's got a frequency counter in it. It's a frequency counter that works. It measures HFE. It measures capacitance. It does everything else that a digital multimeter does. I would check it out. There's some real opportunities there. Even if the thing breaks, $34, get a new one. I mean,
hey, while you're on that, I bought a transistor tester for $17. And this thing, it'll read the HFE automatically for you, and it'll tell you if it's good or bad, or it'll tell you if it's NPN or PNP. And the thing is, you can actually match transistors on this, match the HFE.
It's going to be good for that bag of that big, when you stuck your hands in the barrel. And if you had this device, you would have been, like you always say, it's a great time to be a home brewer. Hey, Pete, let's do SolderSmoke mailbag, because I know time is running short here.
Yes.
I think we've hit most of our targets. Dave, AA7EE, is blogging again. He's back.
Oh, wow.
And he's also doing a lot of Twitter stuff. But Dave, keep the blogging up. We're really glad to see you. Made some really, really beautiful photography and detailed descriptions of the circuits he's built. Another person who's back, who we haven't heard from in a long time, Michael Rainey, AA1TJ.
Hobbit hole.
He's been back in the Hobbit hole this winter. And he's been building a WWVB receiver and time decoder. And Michael, just let us know how these projects are going. It's great to hear that you're back in there and you're melting solder in the Hobbit hole. Um, you know, I guess we should keep this one kind of anonymous, but somebody we know, a good friend of ours, has been involved in producing the little transmitters that go with the Pico balloons that fly around the world. Okay?
They get shot down?
Well, yes, there's been a lot of controversy about these balloons. And because of that, I sent this friend of ours an email saying, wow, you must be interested in all this balloon stuff. And he wrote back to me and he said that he has been busy preparing, quote, his Guantanamo Bay QSL card. Pico balloons. We'll just leave it at that.
Yeah.
Hey, Farhan is coming to the US of A. He's going to be at FDIM, and we have convinced him to make a stop in Northern Virginia. So we're going to get him in here to the shack. We're going to show him some stuff, and we're going to bring him down to the high school so he can meet the students that we've been telling him about and that we've been telling about him. Tony, G4WIF is in a nice note. I mentioned it before about, not just too long ago, he would have spent a lot more than $39 for just a 60 megahertz frequency counter. The frequency counter in this little $34 DMM goes up to 60 megahertz, and it works. We've used it to test the PTO. I mentioned Dean's work on the 10 meter DSB rig, fine business. Oh, also, I've been spoiled, Pete, and this is causing a deterioration in my limited digital skills. So I have a Nano VNA. I need to upgrade the software, the firmware. This could be painful. I just hand the thing to Dean. He hands it back with the software.
There you go.
I have another micro BitX that Roger, Papa Alpha 1 Zulu sent me, but it's got the old software in it, and I need the SI5351 Arduino combination.
Dean.
Boom, Dean, he gives it back to me. I could get used to this. This is good, So
yeah.
I thank Dean for that. And another Nano VNA, a fellow club member, Mike KD4MM, who has also been deeply involved in the high school project, teaching the technician classes and helping with helping and testing a lot of the rigs that the students are making. He had a Nano VNA, an extra one, and he's giving it to me. That will make its way to SolderSmoke Shack South.
Oh, there you go.
After I get
how's the construction coming?
Coming along. We're going to be going down there soon. It'll be done. It'll be ready for next winter. We're ready to go. We got some good pictures of the view from the 7th floor. A lot of horizon there, Pete.
Yeah.
I know, the SolderSmoke Shack South. Ian VK3LA. Ian sent me a message saying, "What happened to all of Chuck Adams' content on the internet?" Good question, Ian. I don't know. I sent him the latest copy of the lab notebook that Chuck had put out, which is really good. Don ND6T, a great friend of the podcast, and a guy who's made many contributions to the kind of the mods to the BitX rigs. He and I have been discussing a kind of a sensitive topic in ham radio: envelope detection. Is it real or is it a myth? There's another sensitive topic, and that is electrolytic capacitors. Replace or don't replace. Man, I found out you really can touch a nerve if you say, "Hey, I went into this rig that I got and I just right off the bat replaced all the old electrolytic capacitors." Fighting words, Pete. Pete got mad. People got mad at me, but I'm with a go ahead and replace them kind of thing. Mr. Carlson in his videos has been replacing them. As soon as he opens the box, he goes in there, pulls them out, replaces them. And I'm with Mr. Carlson on that one.
And they're cheap enough.
They're cheap enough, yeah. And you get nice ones that's good.
Yeah, good. Made here in the United States.
Boom.
Yeah.
Don't wait for these things to explode on you and cause a problem. A lot of these older rigs, you got to be careful. They can cause a fire.
Yeah.
I told you a while back, I was talking to Tim, WA1HLR, and he told me about the danger of keeping older equipment fired up in the shack. And it kind of scared me. I got one of these little Chinese things. Let me see if I can tilt up. You can see it up there. Look it up there. You can see it.
Yeah.
See that little red bulb up there?
Yeah.
Okay, what that thing is, I don't know if it'll work, but after I talked to Tim, I got scared. And that little red bulb up there, if it gets to 300 degrees Fahrenheit, guess what it does? Kaboom! It explodes.
There you go.
And it's filled with fire retardant powder.
Wow.
So if I forget and leave the soldering iron on and it starts smoking, or if I forget and leave the HQ100 on or the DX100 on, boom! Get out of there. All right. I might be overkill. It makes me feel better. I put it up there. It's from China. It might work. Who knows? It might save the day. Nick M0NTV has been working on AM modulators. I told him the problem really is the demodulators. See above, the envelope detectors. But he has a new video, and it's always great to see videos from Nick the Vic. Check it out. Great minds think alike, Pete. Cyprian, Y06DXE, around the same time that I was doing my 10-meter transmitter thing, he was also building a 10-minute transmitter. All right. So he's got a good video up on that on his blog. Steve, Echo India 5 Delta Delta, sent us the most recent edition of the Connacht Regional Radio News. This is one of the most beautiful club-oriented publications out there. He's got a lot of stuff in there. He's got your picture on the latest edition. Your picture is in there, Pete. I'm gonna send you the link. I'm gonna put the link up on the blog. He's got an ad encouraging people to subscribe to Sprat Magazine. Beautiful stuff. I've encouraged him. I said he's got to put something in there for Todd, K7TFC, and mostly DIY RF, because the readers, if they're interested in Sprat and they're interested in SolderSmoke, they'll be interested in Todd's, mostly DIYRF.com. Wow, we covered a lot of ground, Pete. It's so good to have you back.
Yeah, hey, I just wanted to mention, Todd, I can't tell you specifically, but Todd's got some more product there. So more in the works. So more stuff is going to come, so you can just go into his catalog and build a radio.
I'm going to check it out. We're going to do it. One other thing I want to mention before we stop, book review. I mentioned Thunderstruck by Eric Larson. I read it again. It's worth reading. And I must say, I got more sympathy for Marconi after I read this thing. I've been kind of hard on Marconi lately. But when you read about Marconi in the early days of radio, this poor guy was trying to go transatlantic, and there were no books, no circuit diagrams he could refer to. He was doing it pretty much all on his own. And so you get a sense for the kind of heroic efforts that he made. As a pretty young guy. He was like 23 years old when he was doing this.
But his life afterwards is a little bit of a question.
It went, yeah, things kind of went sideways after that. But this brings us to something that I saw up on the Connacht Regional News. April 22nd is Worldwide Marconi Day. So in the past I would have said nah, but after reading Thunderstruck, like I said, I've become more sympathetic to Marconi, especially in the early days. I met his daughter. I told you.
Yeah.
Princess Electra. Yeah. Pete, how long we out here? We're at 1 hour, 8 minutes. We're so glad to have you back. We know you've got to take off. You got other responsibilities. So I'm going to say 7-3 from Northern Virginia.
7-3 from the left coast, where it's wet, snow, and cold.
Watch out for the cold there, Pete. It's bad stuff.
Take care.
Take care, Pete. Thanks a lot.
7-3.
7-3. Thank you.